Start, sir.
I will start, right? Okay. Good afternoon, dear students. Welcome to the second live session on programming in C++. We had the first live session couple of weeks back, and after that you are almost absolutely at the end of the course. So you must have completed all the videos, and some of you have put some questions which I would like to address. And let me start with that. If there are further questions, put them on the on the YouTube chat as you find them. I'll try to answer them towards the end. Right now, whatever questions were asked in the Google response form, and whatever some of the repeating questions that came in the forum are what we have compiled, and I will start with that set. Okay. So okay, so let me get started. I will share the presentation on this. Is the presentation visible? Is the presentation visible?
Yes, sir.
Okay, okay. So this is, as I said, the second interaction class, and along with me, there is Shaurabh from NTL and Himadri, Shoman, and Arup, the TAs who have been helping in this course since the beginning. So first, I will let me start with the questions that you have put on this. So this is a question on polymorphism in C++. Now, in spite of my repeated requests, you still ask quite generic questions, because what does polymorphism mean in C++, Keshav? If you have not understood that after having done the modules, then I would conclude that you have not really gone through them well. Yet, I will just like to point out, so I have taken out certain slides from my presentations to just highlight where the answers actually exist. So polymorphism, as the name suggests, poly means many and morph means to change. So polymorphism means that when you have the same name but different behavior, then you are having polymorphism. So this applies to different types of functions in C++. And there are two primary mechanisms of polymorphism. One we say is a method overloading. In the method overloading, the name of the method is same. There are two methods or two functions, so to say. It could be global functions as well. Overloading applies to global functions as well. There are two functions which have the same name, but they have different signature, which means that one or more of their parameters have different type, or they are in different order, or things like that, so that when I call the function, unlike in C where you identify the call based on the name of the function, because C has no polymorphism, here from the name you cannot make out which function has been called. You need to take the name of the function as well as the types of the parameters to decide what has been called, which particular function has been called. So this is known as overloading, and this is very widely used in C++. In terms of the other form, which is very special to C++, and very powerful is called method overriding. In method overriding does not apply in general. It is between a class and its child class, inherited class. So if between them there is a method which has the same signature, it has the same signature for the base class or the parent class, and the same signature, that is the name as well as the number and types of parameters are identical, then if they have same signature, but one function occurs, one method occurs in the base class, other occurs in the derived class, one is in the parent, other is in the child, then we say that we have method overriding. So these two, you can have method overloading as well as overriding together. For example, here we show an example. This is from module 22, slide number 8, as you can see. So on left, you have a simple inheritance. So you have inheritance. Class B has two methods, and they are derived to class D publicly. So this is a specialization. So class D does not define any f or g function, but it just inherits the functions of the base. So if I have two objects, a object of B and object of D, class D, then if I call B dot F1 with the B object, it will call the F function of B. And if I call D dot F3, that is from the derived class object, that will also call the same function, because there is only one function which is shared between the two. This is a simple principle of inheritance. Now look at the right. I again have the same base class, but what I have done in the derived class, after inheriting B colon colon F, that is the F function of B, I have again given a signature for F, and that is an identical signature. So this is a situation of overriding, because the F in D and the F in B have the same signature. Both have name F, and they have a single parameter of type int, returns void, and so on. But I have also given another function F, which has the same name as the earlier F function, of course, but takes a different type of parameter. It takes a reference to string type. So the first function overrides the F function of B, whereas the second function overloads the F function of B. So that is the basic difference that happens. Okay? And I can have a new function H introduced here. So if I now have again two objects B and D, I call B dot F1, B dot G2, the behaviors are going to be the same as the left side. But if I now called D dot F3, earlier it was calling the F function of B, but now since I have overridden, it will call the F function of D. So you can see that this was B colon colon F, now this becomes D colon colon F. It will call, so that is the effect of the overriding, right? So this also is other kind of polymorphism. In terms of, if you just look at the call site, this looks at D dot F3. This also looks at D dot F3. You cannot distinguish. Here there is no overriding. Here there is overriding. And because of that overriding, I'm calling a different function now. But if I do D dot G4, there is no difference because G has not been overridden in the derived class D. Now, finally, if I call D dot F with a parameter which is read in double quotes, that means it is a C string, which means it is translated to a string reference in C++, then it binds with, it is dispatched to this function F string ampersand, which is a overloading of the function F of B. So now it calls, It does not call B colon colon F int, obviously. It does not call D colon colon F int because it's not overriding. It does not have the same parameter type, but it calls D colon colon F string reference, which is the overloaded version of F. So this is the other form of polymorphism. Right? Now, if you can certainly call D code D dot H5, which is a new function. So these are the two primary forms of polymorphism that we have. Now, in terms of again, in terms of overriding, we have talked about another shade for this. Uh, Another shade for this, which is in terms of what happens if the function in the base is a virtual function. So we will see a form of dynamic polymorphism there, which is another form of, so the overridden functions could be statically polymorphic, as this example shows, or it could be runtime polymorphic, as we can do if we make that function virtual. So there is a different question on that, so I will address that along with that question. Second question, let me move on to from Aditi. If we haven't put any data, then how can we understand that data is private or public? If you haven't put any data, then why do you need to understand? So that question is not relevant. The question becomes relevant if you say that I have put the data, some data member, but I have not specified what is the access specifier. So something like this on the left, you have not specified. Then this means that the access specifier is private. So writing private at the beginning, in the beginning, if you do not write anything, it is considered to be private, whether it is data member or method. If you want it to be public, you have to explicitly write that. So writing is in left as in right are the same. Next question from Bishop Prionath is, are the terms dynamic dispatch, polymorphic dispatch, dynamic binding mean same? So again, these questions are very, very generic, and they have all been addressed very extensively in the videos and the presentation. So I'm just picking up one from module 26. I mean, there are on polymorphism, I think there are 5 different modules which discuss each and every aspect of this. So dynamic dispatch or polymorphic dispatch or dynamic binding are same, but these are different terms because you address it from different perspectives. Dynamic or polymorphic dispatch is a process of selecting which implementation of a function you would use. So you can see the simple example here. This is a basic example from slide 9. You have the class B and derived class D. You have F, which is overridden from in D from B, and you have G, what is overridden from B function, class B into class D, but F is non-virtual, whereas G is virtual. So what that means that when you try to access them from directly by using the object, you do get the corresponding overridden function. But if you access them using a pointer to the base, so you have a pointer to the base where this pointer PB points to a B object, whereas this pointer PD points to a D object. So if you call function G with PB, then you get B colon colon G. Why? Because your actual object is a B object. But if you use the pointer PD, this is also a pointer to the base class. But if you call G with that pointer, then you do not get to call B colon colon G, you get to call D colon colon G, because in reality you are pointing to a D object. So the type of the base pointer is the same. The signatures look the same, the call sites look the same, but depending on what type of object on the hierarchy and what type of object it is pointing to, it calls the virtual function, virtual member function of that particular class. That is the basic nature, reason of calling it a dynamic dispatch means nothing other than actually, you know, making a call from the site. So this is the actual call ppd pointed g, and from that you will transfer the control to the beginning of this function d colon colon g. This process of control transfer is called the dispatch. So this dispatch will happen based on the runtime value, based on the runtime object. So that is why this is dynamic dispatch. It is also polymorphic dispatch because just by looking at pb pointer g or pd pointer g, you cannot make out which function will get called, whether it will be the function which is in the class B, or it will be the function which will be in the class D. It depends on the actual runtime object, and therefore it is also a dynamic binding, because at the compile time, which is called static binding, for function f, the binding is static because it will always call the corresponding corresponding member function corresponding to the type of the pointer, the type of the reference. But when you are making it a polymorphic function, then you have a dynamic binding because at the runtime it is getting decided as to which function will get called. So that's the basic sense of dynamic dispatch. I would also like to refer back to Keshav's questions or polymorphism in C++. So Keshav, you can see that this is the third case or a subcase of overridden functions being polymorphically used in C++. Just for completeness, Keshav, you may also note that there is yet another type of polymorphism in C++, which are based on templates. Since we haven't gone heavy on templates, we haven't discussed that, but templates are also kind of provides you a polymorphism at the compile time. The third part of the question was why does anyone choose dynamic binding over normal member function? Again, Bishop, you should have must study the videos again and very thoroughly, because these questions have been very extensively addressed. Again, for example, I'm showing slide 10 from module 28. So if you look in here, then we have a extensive hierarchy of classes. We have a shape, which is a base class. Then we have polygon and closed conics, which are polygon is a subclass of shape. Closed conics is a subclass of shape. Triangle is a subclass of polygon. Quadrilateral is a subclass of polygon. Circle is a subclass of closed conics. Ellipse is a subclass of closed conics. So this is a multi-layer hierarchy that we have. Now what we wanted to do is we want to write this code. Look at this code. That I would like to have an array of objects on this hierarchy. And I do not know what kind of object could be there. So I have pointers to a number of different types of objects, a triangle, quadrilateral, circle, ellipse, and so on. Now, for each one of them, I want to call a draw function, which will draw that particular object. Now, you will understand that the draw of triangle, how to draw a triangle is different from how to draw a quadrilateral or how to draw a polygon in general. Certainly that is different from how to draw a circle or how to draw an ellipse. So all of these are actually different functions. But I do not want to, like in C, give it different names and then remember as to whether I'm drawing for a triangle or drawing for a circle. I say, okay, I have a triangle object and I will call the draw function on that. It should appropriately get dispatched to the draw of the triangle class. If I call the draw function on the circle object through the base pointer to shape, then it should get dispatched to the draw function of the circle class. So that is my requirement. So I want to write this code that I have an array of, which is an array of base pointers. So all of these are different objects which whose pointers are upcast to the base pointer type. Then over the collection of these objects in the array, I want to write arri. For each one, I want to call the draw function. And when I is 0, that I'm actually pointing to triangle, I need this to go to draw, call the draw of the triangle. For the next one, I want that it will call the draw of quadrilateral. For the next, it should call the draw of circle. For the next, it should call the draw of ellipse. So that is the behavior I want. And you can see from this code that I do not need to remember the type of every object. I do not need to remember the different draw function names and all that. So this is possible because of this dynamic binding. So there are a few things to be noted. One is certainly I do not know the draw function for a generic shape. So I cannot say what is the draw function, and that is the reason we make it a pure virtual function, because I do not know how to. So you cannot create an object of shape, and neither you can draw it. Closed conics have been derived from that. And I also do not know in general how to draw a closed conics. So I have not been able to define a draw function. So draw function remains purely virtual in closed conics also. And therefore, these two are abstract base classes. Someone had a question on abstract and concrete base classes. So you may please note the answer here. So these are the abstract base classes, whereas for the rest, I have defined the draw function. Now, a big advantage of doing this is, suppose tomorrow I want to add, suppose another type of shape into this hierarchy. I have triangle and I put a subclass of triangle saying equilateral triangle, which is a specialization of triangle, and put a even simpler draw function for that. If I do that, then see, I need to just compile my hierarchy, but I do not need to even change, or I do not need to even do anything, touch my main function at all, because nothing is changing in that. Because in that, it will still remain to be ARRI pointer draw, because if I have the object of a equilateral triangle subclass of triangle, then the dynamic binding will automatically take that control to the draw function of the equilateral triangle class. So that is the beauty of the whole thing, and that is the purpose of doing dynamic binding or dynamic dispatch. This is a very, very powerful tool of C++ and a very core idea of C++. So please go through. There are 5 modules specifically focusing on this, different aspects of polymorphism, including the runtime polymorphism of dynamic binding and dynamic dispatch. So please go through them well and try to master them through examples. There have been assignments on that as well on this. Okay, now suddenly comes a very different kind of question, sir. What would be the pattern of the online non-proctored and final examination? And why are you asking these here? Anyway, the online non-proctored examination will be similar to the weekly programming assignments, where we'll be getting only 1 hour time to answer 6 or 7 questions. So that is the online proctored examination, and non-proctored examination, which we'll take from your home. And the proctor examination questions will be similar to the quiz assignments. So there will be MCQ, multiple choice, multiple select, fill in the blank kind of type. So it will be very, very similar in that. Course end date, certainly known. It's ending on 6th November. Examination currently mentioned on 18th December, possibly Mrityunjay. But please keep an eye on the announcement page. It might change, and the final thing will be known on the announcement page. There are a number of general questions. How do I write a research paper? I do not know, Jyotish, in a course on programming in C++. How do I answer that? You have to do research and, write a paper. That's it. That's all that I can say. Problems occur in making objects, so please explain. If you, Rohit, if you do not say what is the problem, what is the code, how can I explain? It can happen because you may not have written the class properly. You may have given a confusing constructor, or you may have made your destructor protected, and so on. So I would suggest that you go to back to module 3, where classes and objects are discussed, and that might help you in this. Otherwise, you put the question with the code example on on the forum, so that we can answer them accurately. What is the use of member selection operator? Question, I do not understand what you mean, because without selection, how do you get the data members and methods of an object? So you got to select the member, right? So you can do that by the dot operator, or if you're using a pointer, then you can do that in direction operator. But certainly without that, you cannot work at all. Anshu, can you explain copy constructor in detail? Again, you should ask questions which are specific. The copy constructor has been discussed in detail in module 3. So copy is required whenever, we have call by value. A call by In call by value, the the actual parameter needs to be copied to the formal parameter. So if I have an object as an actual parameter, I need to create another object which is a copy of the same object, which will take place of the formal parameter. So that is the basic requirement. So in a normal constructor, which takes arbitrary set of parameters or does not take a parameter, a default constructor, in contrast to that, copy constructor always takes the reference to an object that exists and creates a copy for that. Because without that, you would not have been able to do a call by value. Similar thing will apply to, you will not be able to do a return by value unless you have copy constructors. Also, if you want to initialize an object from an existing object, these are the 3 typical places where you need copy constructors to use one existing object and construct another new object. Right. Please explain the OOPS concept. Again, this is very generic. So it has several concepts like inheritance and polymorphism. And this course is particularly on C++ programming. So if you are interested more on OOPS, there is another course by me which ran this semester. I do not know if it will probably run next to next semester. It is called a OOAD course, Object Oriented Analysis and Design. If you want to get into the depth of OOPS concepts, then you can get in there. Otherwise, in terms of C++, the core concepts are of inheritance and polymorphism. Besides the basic concept of objects, which is encapsulation, those are all explained in terms of the entire course in C++. But it always helps if you ask very specific questions. Okay, so we'll move on to some questions from the FAQ. Why do we have explicit keyword before constructor? It is just to make sure that you know the constructor. If I have a constructor, then in certain situations, that constructor can be used by the compiler for implicitly convert cast object types. So if you do not want that behavior for a specific class, if you do not want implicit conversion, then you put explicit keyword in the front of the constructor. In fact, you can have a combination also. I mean, some constructor could be explicit while others may not be explicit. This has been discussed in the lectures as well. Pure virtual function, the last dynamic binding, as you said, a pure virtual function may have a body even, though, yes, that is true. A pure virtual function means that you cannot create objects of that class, but you can still have a body, because you may have some common code for all the derived classes which you would want to put in this function implementation. So I showed an example there. Here, what you can see, an example here, and you are saying that you are getting a error in the compiler. That's always possible, because all this is not a very standard feature. So you might get an error. If you get an error, then just do a simple thing. Just do not define this pure virtual function. That is, do not put the body in situ the class, in within the class. Just put a semicolon after the equal to 0 line, and externally you define the function body. So you have tried to show it here. So you here you declare it simply as a pure virtual function, but then you provide a body. So you say shape colon colon func and put that. So then, more compilers will accept that kind of a code. In terms of what I have said is in terms of what the language standard supports, and what I have shown is what compiles in Visual Studio. But I'm sure there would be compilers where that form, in situ form, may not compile. You have separately defined function style. Abstract class, there is an abstract class with one pure virtual function. Yes, if there is at least one, then the class becomes abstract. A class is derived from this abstract base class without any members. Okay, if it is derived without any members, which mean that the pure virtual function has not been overridden in this derived class, which means that the derived class also has a pure virtual function by inheritance. Now the derived class also becomes abstract class or not? Yes, of course it will become abstract class because it has a pure virtual function. I think Yalamanda, when I showed you the example of shapes in the earlier question, then we were also seeing that same thing. So actually I can take you back. We had a specific example. For example, we have shape, which has a pure virtual function, and we have closed connex, which is just derived from it. It does not have any member. And certainly closed connex is an abstract base class because it has not overridden the draw function and defined it. Okay, overridden as a non-pure. So your guess is correct. I don't know. This probably was some question. People probably wanted to see where the languages stand. As of now, C is replaced Java uh, from last year. From this year, C has replaced Java as the number one, the most popular language, and by quite a significant margin, 4.5% margin. Actually, if you take C and C++ together now, it is 2017 and 7, about 24%, about 25% popularity is with C, C++, which is also very close to C sharp. So there's a significant amount of language family dominance of the C, C++ group in the general, at least open source projects. These data are computed from open source projects. Okay. Other questions? Do have some regarding certification exam will be held offline. So what will be the exam? So this is answered here. There'll be, I think I already talked this. There'll be a proctored online examination, which you will take from home, which will have to be taken from the examination center, the allocated examination center. You'll have to, be in touch with the NPTEL office regarding details of that. They will let you know and tell you the documents to carry and so on. And there'll be a non-proctored or offline examination, which you will take from home, which will be for 1 hour with 6 to 7 questions. The proctored one will be very similar to quiz assignments, multiple choice, multiple select, and SAQ must be short answer questions, which is you fill up the blanks kind of. And the total marks for this will be 80. And for your non-proctored programming test, it will be like the programming assignments you did. The total marks will be 20. So 20 and 80 will be the 100 marks. The percentage of computation, this is the percentage of computation. The final score is 25% of assignment plus 50% of the online examination score. which is a proctored one, plus 25% of the programming, which is non-proctored. And here are the passing criterion given as to if you get assignment score is more than 40% and programming score is more than 40% and proctored examination is more than 40%, then you'll. So this is there's some formula set which is shown here. So you can, if you want, you can keep that in mind. I think this was all of the questions that I already had. So I'll stop this sharing. I still have 10 minutes. If there are some questions on the YouTube chat or somewhere, then Shoman Himadri, is there anything that I should respond to here?
No, sir.
No, sir.
No,
There are
sir.
many questions.
Also, you have. I think you have either answered the question on the chat or the questions. Some of the questions already uh, are already addressed in terms of the uh, clarifications that we gave to the earlier questions.
Yes, sir.
Okay. So, Shaurav, it should be back to you because there are no other questions coming. So let us know, should we wait or? Shaurav, are you there? Shoman or Himadri, could you call any one of them? The numbers were given in the mail.
Yes, sir. We are calling.
Because if there is no other questions coming in, then.
Sir, there is one question I have posted in chat.
Okay. Oh, please explain inline function. Inline function are there is, in terms of programming, in terms of the programmer, inline functions have no specific significance. I mean, they are just like any other function. The fact is the inline, the word inline is a kind of suggestions being made to the compiler, saying that when I call a function, then a lot of, I mean, other things also get to happen, right? I need to collect the parameters, then I need to copy the the actual parameters to formal parameter, then I have to transfer the control from the current function to the function being called, which has the effect of remembering the return address. Then I go to that function called, I do the computation, then again I have to return. So while returning, I have to again copy the return value back and make indirect jump to come back from the called function to the calling function. So all these are involved in terms of the calling function. Now, if a function body is very small, suppose a function is just incrementing the parameter value, just increasing it by 1, that's the function, or even a swap function. which has 3 transfers to do, 3 assignments to do, basically, if you look at. But for doing that, we are adding a lot of computation at the runtime, which are not that way useful. I mean, copying formal parameters, then making transfer of control, remembering the return address, bringing the value back, doing indirect control back, and so on. So it may be in some cases a better idea that instead of calling that function, we can put that function code in some form right at the location where the function has been called. So when you do that, so what will happen is the same effect will happen. So I've called a swap function. So instead of the function, only those 3 swapping statements, assignments will be put in place of where the swap has been called. So that will significantly reduce the overhead of function call and return. So that, if I can do that, then there is a lot of speed up that can happen. Now your question would be, why don't we do it for every function? Now in general it is not easy, because if you have to inline, you have to take care of a lot of other things, like the called function has local variables and your calling function has local variables, their names will clash and so on and so forth. So you have to rename the local variables of the called function and so on. So if the function has a large body, then the overhead of calling the function is worth it. That is, copying the formal actual parameter, and then making the jump, copying the return value back, making the indirect jump back. These are worth it. If the function body is small, then this may not be worth it. So when you put the inline function directive to the compiler weighs between the 2 options, and if it is good to inline, that is, put the code right at the place of call, it does that, and that improves a significant amount of efficiency. So that's the basic idea. How virtual keyword works internally? It is again a directive to the compiler. So the compiler knows whether to generate a static binding or to generate a dynamic binding. So if you do not put virtual, the compiler will directly put the address of the function, because it knows which function is being called, which particular method of the class is being called. If you say it is virtual, if you say it is virtual, that it is runtime polymorphic, then instead of putting the function directly, it will put a pointer to the virtual function table. It is typically called vtable or VFT, where by location, this particular function will be. So you will say that I want to call the 3rd virtual function of this class. And depending on which function reside there, that will get called. So the 2 mechanisms become very different. There are explanations of this given in the video as well. You can look up, but that is a basic purpose, that virtual tells the compiler that you go through the virtual function table so that you can have a dynamic dispatch. Without virtual, it tells the compiler that you directly statically bind and do not go through the virtual function table. So that's the basic difference. That's all, Showman.
Sir, we have another question.
No matter how you call the constructor cannot return anything, because constructor's purpose is not to compute. Its constructor purpose is to construct the object. So I do not really understand if you say what is calling explicitly. You are actually calling the constructor explicitly. Only thing, the call syntax is so different that you don't see that you are calling it. So if you have a class B and you're saying that small b is an object of class B, then you're actually putting a call. The compiler will actually put a call to the constructor. It's just that you are not being able to see that. But no matter how the constructor is called, there is nothing to return, because if the constructor is called, then you give it adequate amount of memory where the object of that class can fit in, and the constructor initializer and the body will populate the data members according to requirement in that space. That is the purpose of the constructor, not to return you any value. That's the reason that no constructor has a return type given. Its just purpose is to populate the, I mean, it's called a constructor because you are constructing the object, but it's actually what it is doing in the given memory. It actually initializes and builds up the each and every data member. That's the purpose. I think that's all, Shoman.
Yes, sir.
Saurav, are you there?
Yes, sir.
So I think we are done. We have answered all the questions that came, and we are also, according to the clock, we are already up by 1 minute.
Okay, sir. So I'm ending the session. You just wait for 1 minute, sir.
Okay, I will.